one. We're live.
Welcome to Physical Science in the AM.
Who's your host?
And this is your host.
Thank you. Okay, we had just talked about this before computer problems. Molar mass. Okay, it isn't practical to talk about the number of actual atoms because there's huge numbers involved. Instead, we talk about a mole of atoms. We don't need to know the number of items in a mole, but the periodic table, as long as you use molar masses, you'll know you have the same number of atoms, 1 mole of atoms of this type and 1 mole of atoms of that type. If you use the grams and moles on there. Now, if you want to find the mass of 1 mole of an atom, we just look on the periodic table. What we're going to do right now is just, for example, use sodium. Now, in case you've forgotten, sodium is Na on the periodic table. On yours, you're going to have these ready later on. You look up Na, and you just say, well, that's 22.99. I got that number, little decimal number there. Yours always have 2 decimals. And we're going to use a flat fraction, grams per 1 mole. Okay? Now, I'm going to put that fraction line all the way over. I don't usually put the 1 mole in there, but you understand that? Oh. And I'm going to put down N. This is a fraction. You can flip it if you need to. And I'm going to say, this is the same information. For sodium, for example, 1 mole of sodium, I could write it this way, 22.99 grams. It's the same information, but just upside down, right? Sometimes you want it that way. And we'll see when we get into it. Every gram per mole can be flipped for moles per gram. Just a different way of thinking about it, right? We'll talk about the conversion math later. We will bring up this YouTube video here. And if you're watching online, I'll just show you after this brief message from Grammarly. You need to Google up or YouTube up how big is a mole, not the animal, the other one, Daniel Dulip. I'm going to pause the recording because these don't record very well. But do that if you're on the record. So if we have the sample of 18 mils of water in front of us, let's find the molar mass of a compound, add up the mass of each individual atom to change the compound. Like, how did I know that 18 grams of water is a mole of particles? So, you have to know formulas. And I think we know the formula for water. I'm sure. H2O. Okay. So first, let's do this. This is what I'm thinking. And you've got to have your periodic table. So I don't write this out, but right now, like when I'm doing these, most students don't. That's the first few examples. If you need to, you can. Put this directly in the calculator, which I'll bring up my calculator. Okay. Disregard. Actually, that's, I thought there was calculus. Last time we did molar calculation. Okay. So what I'm thinking is that this, so I'm putting in green what my scratch work is that I wouldn't normally write on. But hydrogen, there's 2 hydrogens. And there's 1, and I'm going to do a handwriting oxygen so you don't think that's 1 oxygen atom. Okay. And then I look up, well, what's the mass of 2 hydrogens? This one I can do in my head, but usually they aren't numbers like 63.55 and stuff like this. So what I'm thinking is that I'm going to put this on my calculator. I'm going to go 2 times 1.01, which I get from periodic table. The oxygen, I'm not going to put 1 times, but it is 16.00. These are in grams. And then I'm going to add those up. I'm going to multiply the hydrogen. So, here I go, and this is what you do on your calculator, 2 times 1.01, don't be lazy, you need the second decimal, plus 16. This is why 18.02 grams is the mole of water molecule. So I add that. Now, that's just scratch working, right? I really only did that so you know what I put into my calculator. You do that in your calculator, and then 1 mole of water is 18.02 grams per mole. You can put the 1 mole if you wish. I'm going to put the H2O attached. You need units and the count. I guess I don't really need, I put this down because we were talking about it. You don't erase it, but I mean, I'm just emphasizing this is the water's molar mass. I'm going to erase my green work there. No, I'm going to just shrink it because I'm going to do some more work. This is my scratch work for them. How about magnesium nitrate? Well, son of a bee. I need to know the formula for magnesium nitrate. Luckily, on the back side of your periodic table, you can figure this out. So, I'm thinking magnesium, Mg2+, when I look it up on the iron chart. Nitrate, well, that's not in the periodic table. It's one of the ones in the center, the polyatomic. That's NO3 with a minus. I need to do this, at least in my head, that's why I'm putting it as green, to know that the formula of magnesium nitrate is Mg bracket NO3 twice, O2. You need to do that before you figure it. Then, more green work on my calculator. I usually just look at this and see, okay, I got 1 magnesium. I go list this. This is what I'm thinking. 1 Mg. Look at it. Then, this 2 means I've got 2 alkyls. So that means 2 nitrogens. 2 times 3, 6 oxygen. This making sense? No? Okay? So I'm going to put down 2 nitrogens because of the bracket, and 6, 2 times 3, oxygen atoms. Okay? So this is what I'm going to add up. My scratch work for this one. Put a little box. So no, that's not part of this. So I look up 1 magnesium on the periodic table. 1 magnesium, 12, 24.31. 2 nitrogen is 14.01. So I'm going to put down 2 bracket for times 14.01. And then 6 groups of oxygen, that's 6 times 16. I still put down the 0.00 because I know I'm being that careful, but I'm keeping that many down. They're significant digits. So on my calculator, I'm putting 24.31 plus 2 times 14.01 plus 6 times 16.00. When I add that up, I get 148 decimals. Put that here. This isn't the final answer for this measure. 148 decimal 33. That's my scratch work that I did on the top. So I still haven't answered the question directly. Find the molar mass of the compound. To find the molar mass of the compound, add up the mass of each individual atom of the compound. Sure, I've basically done that, but magnesium nitrate's molar mass is 148.33 grams of MgNO3 bracket per 1 mole. I don't need the 1 there, but I do need the flat fraction mole. Is there questions how we do this. Basically being able to count the number of atoms inside a formula. Careful to say formula, not molecule. Water is a molecule, but ionic compounds aren't considered molecules. Have to look at their compounds and their formula. So I've mentioned this before, but in the lab we measure amounts in grams. So we use molar mass to convert from grams to moles, or vice versa, moles to grams. Now, spool of copper wire, you guys can see it before. Last time I weighed it, was 74.9 grams. We used a little bit of it, so it won't quite be 74. And that's ignoring the plastic. The plastic doesn't weigh as much as this. But this 75-ish grams of copper, right? So, find the number of moles of copper in this. Well, this is now multiplication or division. We got to figure this out. When we start a problem, always write down the, when I say single amount, the amount that's not a fraction. It's either grams or it's moles. In this case, it's grams. I'm going to put 74.9 grams. And I do label what it is. One, I chose the first one to be simple. You know, like H2O. It's just copper. So you look up on your periodic table for copper. 63.55. Now here's what I'm thinking. 63.55 is the grams for 1 mole. You know how up here I said, well, you can use grams per mole. The same information flipped is moles per gram. That's not a mystery. You still get the numbers. The one mole, is married to the mole. It's not going to ever change. So if you flip, the 1 will go with the mole. The decimal number from the periodic table is always attached to the gram. Now, here's the reason why I'm bringing this out. That I want to get rid of grams, so mathematically, I know that grams on the top and grams on the bottom cancel. I want moles, so I'm going to put the 1 mole here. And then I look it up on the periodic table for copper. I already said the number. It's 63.55. And you're going to get more familiar with the periodic table, not to get the numbers, where things are. For copper. So mathematically, this means 74.9 times 1. Anything on the bottom of a fraction is a division point, divided by 63.55. Now, the ones I kind of ignore, you should see. Multiplying or dividing by 1 doesn't change the number. But it's important to hold that position. So, on my calculator, I'm going to go 74.9 divided by 63.55. Now, that's a little over 1 mole. I used 4 significant digits here, but I have 3 significant digits there. My answer needs to be the least number of significant digits, in this case 3. It's not decimal places, it's significant digits. So I'm going to call that 1.17, not quite. Like here's what the calculator says. 1.1785, blah, blah, blah. Okay. I need to keep 3 of these digits. So this, but I don't chop it off. I use proper round. That 8 tells me anything 5 or higher, you round up, right? Let me put 118 as my answer. 1.18. Now, unit-wise, I've gotten rid of grams because that's what I wanted. What you want to get rid of on the bottom fraction, what you want to keep is moles. The number of moles of copper. And I put MOL. That's not a spelling error, that's the abbreviation for moles. And I have to label what kind. Take off my. So, remember using zinc? It was the stuff that looked like metal chewed up gum. That experiment requires decimal 250 moles of zinc. So this is the underwear. So, then, what is the mass that needs to be measured out for the experiment? Well, we start with the single thing that's not a fraction, the moles or the grams. In this case, it's moles. 0.250. The symbol for zinc is Zn. And then I ask myself, whoa, huge mistake. What did I forget? Mole of zinc, MOL. That's our unit that we want to get rid of. This step, you ask yourself, what do you want to get rid of? Cross it out to the bottom. So moles on the top for the original thing, moles on the bottom here. I know that it's always 1 with the mole. And that 1 as far as significant digits is as many significant digits as you like. It's the definition of molar masses for 1 exact mole, 1.0000, as many. Then I look up zinc. And zinc on the periodic table, 65.39. Just a second. On your periodic table, it's 65.41. Different period. We're sticking to what you guys have, right? And that's just over the years they get more accurate and stuff. I don't know which one of these two is older. That's 2002. This one's that's 2006. So anyway, I'll always default to the one you guys going forward. And that is grams. You must put in those units on it. No shortcuts. Do it neatly so I see this. When I'm marking these, I need to see this. Now, this means mathematically 0.25 times the 65.41. I don't need to enter the line, but I could. So, 0.250 times 65.41. And I get 16.3525. I've got 3 significant digits and 4 significant digits. That means 16.35. And you can chop it off at the decimal 3, but it pushes it up. I'll write that out. 16.3. And then 5 behind. I need to round up. I'm going to put 16.4. 16.4. This is moles gone, grams, and the chemical is zinc. There's a full marking. How would I mark this? Generally, I do a calculation like this out of 2. One of the marks is for the 65.4 and setting it up like this. The other mark is for the answer with units. Okay? You get 1 out of 2 if you just put down 16. 16.4. You need the ground. Okay? That's how you do it. So that means. Well, let's try a couple of these, and I'll let you try. What's the mass? What's the mole? Mass is grams. Moles. What's the mass? Just randomly, I see like 2. Okay. 1, 2, 3, or 4. Which one looks the most different? Tell me, we'll do it. Ready? Okay. How many moles of NH4? Bracket. So that's ammonium. 3. No, that's ammonium phosphate. All right, 15 grams sample. I'll never see them. I'm going to start with 15 grams because you always write the single item down. Just start blindly without any pulling on these problems. So we're going from grams to moles. going to put the formula in. I need to do that. Now, I was nice enough not to give you this in words, otherwise you'd have to look up what the formula is. It takes a little bit of time. And I know that I want to get grams on the top or grams on the bottom. I want moles, so I put moles on the top. We now need to look up how to find that number of grains. I'll do this in green. Do this directly on the calculator. I think of this as 3 groups of nitrogen, 12 groups of phosphorus, 12 groups of hydrogen, 1 group of P phosphate, 4 groups of oxygen. I'm going to list down what I just said. So that's 3 groups of nitrogen, 12 groups of hydrogen, 1 group of phosphorus, 4 groups of oxygen. Now, this is what I'm entering on my calculator. So I'm going to go 3 times 14.01, 12 times 1.01 for hydrogen, 1 times, I don't even need the bracket there, molar. Phosphorus is 30.97. I'll do that one. It's going to be the ratio. And 4 times 16. I put all of those in my calculator. So 3 times 14 plus 12 times 1.01 plus 30.97 plus 4 times 16. I get an answer, and I'm going to keep it to 2 decimal places. That's what it came out of. 149.12. I'm going to put that in. 149. This is worth a mark, 1 out of 2 already. I haven't even touched my calculation go as far as this to get the final mark. I need to go 15 times 1 divided by 1. 15 times 1, I don't need. Divide by 149. Point. 1. Okay. 3 digits in 15.0. The other one is 5 digits. So we're going with 3 digits for this answer. 0.10059. I need to round it. So I'm going to erase this in a second. 0.10059. But I need to round to this digit here. So 0.101. What I'm actually going to write down. And that is, grams are gone. Moles. And then I'm squeezing in the formula. I'm going to erase my scratch work, or maybe I'll just reduce it. Just so I have space. So that is ammonia plus. Okay. Try the other 3 on. Convert to grams. That's what says what is the mass. That means what is the grams. Go from moles. That so the fraction would be upside down. You've got some time to do the other 3. You're going to do them in class. We're going to take them up. Okay. Pause the video while I'm working. Okay, I'll quickly run through the answers to make sure you're on track. 15 gram sample. So it's a 15 gram sample of NaCl. We know that we want to get rid of grams to keep a mole. Na plus Cl is, how much was that ACl? 58.44. When I do that, the grams cancel. We're going to get moles of NaCl. So 15 divided by 58.4. And I get 0.25, and I round it up to 7 moles. Okay? And then mass, how many grams? I have a 1.83. So, okay, and then this one here, I gotta go 22.99 or 22.99. Plus 3207 plus 4 times 6. I got the grams on the top. I multiply. Yeah. 259.9, so I got to call it 260 grams Na2SO4. The last one is now the bell's going to ring. Well, feeling. Anyway, time to flux. So this one here, when you looked it up, let's say, well, there's 2 carbons from here, 2 carbons from there, so 4 carbons, 6 H's, 2 oxygens times 2 is 4 oxygens when you added that up. That's a lot. I know the bell's going to ring. Somebody have a good answer for that? 3 what? 325-ish. Okay, I'll see what I get. And you guys are welcome to go to the bell. If you got 325, we'll see if that's good. Okay. Okay, 325.2. People get 595? I'm only keeping 2 digits, and then I'll help keep it.
Your outfit is so cute. I should have worn my dress. I was like debating between wearing either.
Okay, I'll start with